Okay, now what we are going to start, this is our first lecture of electronics, chapter 10, amplifier frequency response. So this chapter is very important for the exam point of view. Okay, so here we start first. What is amplifier? Amplifier, which is used to amplify the signals power of any device. Okay, and in which includes you can amplify the current, voltage, signals. These mainly used for broadcasting, for audios. So this is very important electronic device. Okay, so now we have discussed that by changing amplification, what we will get. Okay, now in introduction we used two words in amplification, that the coupling and the bypass of capacitor. So when we talk about the capacitor should be biased in two ways. The first name is going to be called as the coupling, and the other one is bypass. Okay, so mainly the capacitor is used to amplify the signals. Okay, to control on it. Okay, so when the AC signal is allowed to pass through the device, okay, so there should be a capacitor. When we give some frequencies at different ranges, like at low frequency and high frequency, we have to see that what is going to be happen after applying at high or low frequency AC voltage. Okay, this is the input signal frequencies which we have to give to our device. Okay, so now we can see that after applying capacitor at different frequencies, but the change it will be formed. Okay, so let's go for first. We have to discuss the effect of coupling capacitor. So you can see this is the reactive capacitance. This is the formula we have studied already. Okay, so the capacitive reactance, which is equals to 1 over 2 pi fc. F shows frequency and C shows capacitance of capacitor. Okay, and this is the reactive capacitance, which is actually the resistance. Okay, so the capacitive reactance is inversely proportional to the frequency and capacitor. So when there will be a high frequency, it means the capacitive reactance will be low. Okay, and if the frequency is low, it means then the capacitive reactance will be large. So here you can see in coupling capacitor there are two capacitors are mainly used. C1, you can see the diagram, these capacitors C1 and C3, which shows the coupling. Okay, so when you give some suitable frequency using input signal, okay, it leads to this C1 capacitor. Okay, then it leads with R's. This is the input resistances. Okay, it is mainly actually we can say this is the lead circuit. Lead circuit is mainly RC circuit. This is the combination of these both resistor and capacitors. Okay, then we say that this is called lead circuit. It will form lead circuit. Okay, and further we will see at high frequency, the capacitive reactance will be low. Okay, then the voltage drop will be obvious, small. It's mean that there is some voltages will be go through this resistance. Okay, now further we can say that at low frequency the capacitive reactance will be large. It's mean that the voltage will drop. Okay, and that must be large obvious, and the voltage gain will be low. Okay, the voltage gain will be low. So there is a formula for voltage. Then the voltage gain will be from this is the ratio of output and input. Okay, now you can see there is another capacitor C3 which also shows the coupling capacitor, and these makes a lead circuit with RL, okay, which is in series with this RC, okay, and this is the capacitive resistance. Now further we can see, so this is all about from about the coupling, okay. So this is another diagram, JFET, okay, junction field effect transistor, and this is the bipolar junction transistor diagram. And you also have studied this gate and source and drain, these three parts of this amplifier. And there are also three capacitors, and first we have to discuss only two capacitors there for coupling, and this third capacitor shows a bypass capacitor. Okay, now further we have to discuss this. So the process of this JFET is same as just like previous BGT, okay, and there is no big difference between it. So further, now we have to go towards effective bypass capacitor. So first we have to discuss that at lower frequencies. Obviously at lower frequencies the reactance of the capacitor will be large. Okay, so here you can see the emitter which is grounded. Okay, so after applying some input signal which is at low frequency, these emitter will no longer at AC ground. Okay, due to this high capacitive reactance value which is in parallel with this RE resistor. Okay, so we have to see that at high or at low, what will be the effect on voltage gain. So further you can see there is an example when the capacitive reactance is approximately equals to 0. This is equals to 0. So the voltage gain is what? You already know that when we talk about the resistances, resistances and amplifier, because there is a PN junction between amplifier in every amplifier. Okay, so there must be some internal resistances of an amplifier. So you can see when the capacitive reactance is 0, so there is no effect, there is no voltage drop, so it's mean, and then we have only the internal resistance. Okay, so you can write it down there, the voltage gain which is equals to this the capacitor reactance, okay, and this is the resistance of capacitor over the internal resistance of emitter. Okay, so there is no capacitive reactance because it is almost equals to 0. And when we talk about the capacitive reactance which is greater than 0, okay, then we say there is some voltage drop obvious, and the combination, because there is capacitive reactance, it's mean which is parallel to this RA resistor, so it's mean the combination of these two resistors gives impedance. So impedance is what? Impedance is the combination of two resistances, which is the capacitive reactance and other is emitter resistance. Okay, so you can write down the voltage gain which is equals to the output over input. So output is which we get uh, from resistance of capacitor and collector. Okay, this is the collector resistance over this internal resistance plus impedance.